In the last video, we left off by downloading some data. Now we have our data path here for our pizza, steak, and sushi data for Food Vision Mini. And I also issued you the challenge of turning our downloaded images into tensors, but more specifically PyTorch data loaders. And we saw in the last section PyTorch transfer learning with the latest Torch Vision 0.13 plus. There's two real ways to make transforms, and that's manual creation or automatic creation depending on the model weights you're using. So let's take a look at this. You might have already done it, and if you have, I applaud you for your efforts, but let's check it out together. So we're going to be creating data sets and data loaders. So let's start off with 2.1 is create data loaders with manual transforms. And the goal here with our transforms, I'm just going to write this down. The goal with transforms is to ensure your custom data is formatted in a reproducible way, as well as a way that will suit pre-trained models. So that's an important point. We saw that in the last section, transfer learning, that if you're going to use your own custom data with a pre-trained model, whether it be a computer vision model or a natural language processing model, it's important to make sure that your custom data is formatted in a very similar way to what the pre-trained model was trained on. Otherwise, you may get performance degradations compared to the pre-trained model's results. So let's see how we can create a manual transform. Let's go set up the directories. We'll get a train dir for a path to our training directory, image path, and train, and then we'll get a test dir. So our image path is just this path we've created up here from our download data function, and test. Then we can have a look at both of these, train dir, test dir. Beautiful. And since from the last section, PyTorch transfer learning, we're building upon that here in section 7. We saw that our transfer learning model performed quite well. So we're going to be reusing transfer learning models in section 7 when running multiple different experiments. So we also learned that if we go to Torch Vision, the documentation, many of the pre-trained models are pre-trained on ImageNet. So if we look up ImageNet, here we go. So all pre-trained models expect input images normalized in the same way. So that means they'll be normalized in this way. And again, this is with the PyTorch documentation Torch Vision 0.12. This documentation will change slightly when you get to 0.13 onwards, which is, if I go to the unstable version, this is 0.14 onwards. But with, do we have 0.13? No, it's not going to show up, is it? Models and pre-trained weights, maybe it will in here. 0.13, yeah, there we go. So this is what I'm talking about. As of version 0.13 onwards, there's a way to automatically create transforms. So the reason why I'm showing you the manual version as well as the automatic version is so you're familiar with both ways. The manual version will just give you more flexibility, but it has the downside of potentially mistransforming your images if you're creating them by yourself. But let's just start off with the manual version. I'm going to copy this normalization transform. What that is going to do is make sure our images have the same distribution, in other words, mean and standard deviation, as the pre-trained model. The pre-trained model is trained on ImageNet, so the same data distribution as ImageNet, and this is how that distribution was found. So let's jump into here. We will go set up ImageNet normalization levels. We'll go normalize equals that, and see here. So just beware if you're using Torch Vision 0.12 or onwards or 0.13 onwards, the documentation might be slightly different. So just keep that in mind. The principles still remain. So create transform pipeline manually. So what I'm going to do is from Torch Vision, import transforms. We'll go manual. I didn't need to re-import it. We've already imported it. I'm just making sure you know where it's coming from. Transforms.compose. And then we're going to fill this in with transforms.resize. And then I'm going to, by default, resize things to 224, 224. Transforms.toTensor. That's going to make sure all of our images are in the range of 0 to 1, and then we will normalize them there. So this pipeline, resize, in line with what it's saying here. Height and width are expected to be at least 224, loaded into a range of 0, 1, and then normalized using these values here, which is what we've got there. Wonderful. Let's keep pushing forward. So let's get a printout of our transforms. So let's go manually, created transforms. And now, of course, if we wanted to add more transforms in here, such as different forms of data augmentation, we definitely could do that. So that's the benefit of creating our own transforms pipeline. Now let's create some data loaders. We can do that with train data loader, or actually, I'll just show you here. From going modular, this is the power of reusing our code that we've written before. Import data setup. So if we go over into going modular, we have a little Python file here called data setup. And inside there, we've got create data loaders. So this is going to help us create a data set using the image folder method from PyTorch datasets. And then it's going to return a train and test data loader. So we've written that code before, but the benefit of using our own script is that we don't have to rewrite everything over and over again. We can just import it and use it here. So I'm going to go data setup.create data loaders here. And then I'm going to pass it in a train dir, which will be what? It'll be our training directory above, training directory up here. Then I'll pass in the tester, which will be tester. And then I'll pass in the transform, which will be the manual transforms. This is going to perform the same transform on the training and test data set. An enhancement to our datasetup.py create data loaders function would be have a different transform for training and test. So you could go test transform would be transforms.compose, and then you could change that down here to have data loader, or sorry, here, test data would use the test transform. So that's one enhancement we could do if we wanted to perform different transforms on each split. So that should still be fine. And we'll set our batch size to a default of 32. So let's see how this goes. Train data loader, test data loader, class names. Beautiful. So there's our manually created transforms pipeline. We can compare this to the automatic one we'll create in the next video. And there's our class names, pizza, steak, and sushi. Wonderful. So let's in the next video create some transforms automatically. You might want to give that a go yourself because we've done this before in the previous section, creating a transform for TorchVision.Models auto creation. So since we're going to be running multiple different model experiments, we're going to be using EfficientNet B0 as one of them. So give it a go, practice creating an automatic transform, just like we've done in section 6, 2.2, but do it for this notebook here. And then we'll do that together in the next video. I'll see you there.